We have these three areas of memory, right? Global space, the call stack, and the heap. And we know how some of these interact. In particular, we know how global space interacts with the heap and how call frames interact with the heap. But how does global space interact with call frames? That's an interesting question. Let's look at an example here. Here we have this function called swap, and we have a rather incomplete but rather cryptic specification here that says that it swaps A and B. Now, what does it mean by that? I mean, I have these two global variables here in A and B. Does it swap them? Well, let's visualize and see what happens. So I'm going to define the function. That's going to create a variable called swap. And now I'm going to create some global variables A and B. And now I'm going to call the function swap. And what this does is this creates a call frame. It creates two new variables A and B, copying the result of the global variables into the parameters. Now I'm going to step forward, and indeed it does swap the two. But this is a procedure. There's no return here. And we're not working with objects, at least not objects that we can modify, so everything's going to be lost when I erase the frame. I swapped these local variables, but I threw away all that work. I suspect that the person who wrote this function probably meant that they wanted to swap the global variables A and B, but we couldn't do that because what happens when you call a function is it copies from the global variables into the call frame. You're never working with the original variables. So does that mean we can never access variables that are global inside of a function definition? Well, not necessarily. Let's work at another example here. And this one's rather interesting. You'll notice that I have created a global variable called A, and now I have a function called getA. And it doesn't actually have any variables in it at all. It has no parameters and no local variables. Instead, I'm going to return the variable A. You might think, okay, this is going to crash when I call it because there's no A here. But let's watch what happens. So I'm going to create the global variable A. I'm going to create the definition. And now I'm going to call it. And I'm going to execute this line with the return. And you'll notice that it returned 4. There's no A in that call frame, but there is a global variable there called A, and it knows to access that variable and return it. So yes, I can access global variables from a call frame. I mean, think about it, right? All functions, all their names are global variables. If you couldn't access those global variables, you would never be able to call one function from another. So I have to have access to global space. But the access to global space is rather limited. Let's look at one more example. So now I have a function called maskA. I have a global variable called A, and I'm going to reassign A to 3.5, and I'm going to return it. Let's watch what happens. I'm going to create a global variable A. I'm going to define the function, and I'm going to call it. And now I'm going to assign A to be 3.5. And watch what just happened. The minute that you assign a variable in a function definition, it creates a local variable in the call frame, even if it has the same name as a global variable. And now what happens is we're going to return A. And Python has a choice because there are two A's. But as we've seen many times before, when Python has the choice between two of them, it will always use the version in the call frame first. It only goes to global space as a rollback if it cannot find that variable in the call frame. So what this means is I can access a variable in global space if I just want to look at it. But inside of a function, I can't change it. Well, that's interesting. So why have global variables at all? Well, we have global variables for what are called constants, things that represent something that I don't want to change. Things like pi inside of the math module. If that's what you're going to use your global variable for, that's fine because you can access it. Well, you just can't change it. Well, actually, you can change variables or global variables from a function definition. So I'm going to show you one last thing. But I want to preface this by what I'm about to show you is very, very bad code. And you should never do this. I'm only showing it to you for completion. So I'm going to create a global variable called for. And now you'll notice at the beginning of my definition of change A, I have added one more command. I've added the word global, and I follow that with A. I have told Python that I have a global variable called a, and that is what you should be using in this function definition. I'm going to visualize this. I'm going to create a global variable called for. I'm going to define the function definition, and now I'm going to call it. And it knows that that a is a global variable. So no a is created inside of the call frame, and now when I return the value, it's 3.5. So yes, we can change a variable in global space. But as I said, this is bad code and you should never do that. Why not? Because the purpose of functions is to sort of keep our code together. If you start changing global variables, now you're changing things all about the file, and this compactness and the locality of the function is completely lost. That is bad for programming, and that is why we avoid that in this course.